All right, so here we're going to be looking at some introduction to differential equations. Now, this topic here, this particular learning material here will take an entire separate course here. So here we're going to learn just the introduction, but just enough basic so that we can see how the calculus 2 is directly applied to this. Okay, so let me bring up a couple demonstration problems here. But to begin with the idea, let's just start out with having, I'm going to say, as a convention to set out right here. Okay, I'm going to say y here, we're going to define a variable y to represent some unknown function f of x. So right now, f of x is unknown. And we generally regard to that f of x here, the output of that f of x is some variable y. Okay, and so in that way right here now, so right from Calc 2 that we've been through right here, right from calculus 2, that we've seen things like that quite often. Let's say, and for now, I'm going to just let y be equal to f of x, and f of x is unknown. So my first equation here I want to bring up right here, and this is very common to anyone after learning a while in calculus 2. Let's say we have y prime equals 2x. Okay? With that equation, y prime equals 2x right here. And then let's say, what's the goal of this? What you have here is an equation. What's the goal of this equation? Let's say out of that equation we want to find y. Okay, we want to find y. So connecting this right here with connecting this goal with that given the function here being an unknown function, then our goal here is so now applying that the information into this particular equation I brought up here. Then what I'm seeing here is the y in this function is unknown. I mean the y from this equation is unknown. What we have in this equation here is a relationship y prime. It reads y prime meaning the derivative of f. This is another way of seeing that derivative of f. Okay? F prime equals 2x. So in this equation, y prime, the derivative of f, is explicitly written as a 2x here. So the y prime, the derivative is known, but the function is unknown. Okay, so now I want to emphasize that the derivative is known or has some relationship as an equation, and then y is unknown, and that's why we want to find y. Okay, and so for anyone learning calculus 2, then this goal of the problem right here is very common. We simply find y by taking the integral. Okay, taking the integral on this given, and the way how it's written right here, then now we have an explicitly given derivative. So we can simply find y, right, or that function, that unknown function f of x right here by taking the integral, okay, of the 2x. And then that's how it comes out to being, and y from our calculus 2 understanding, it comes out being an x squared. And then anyone after learning calculus 2 should be also well familiar that you are required to put a plus c here, indicating that we have a whole family of integral, okay, of antiderivatives. Okay, so now, ladies and gentlemen, at the very basic, right from your Calc 2 class that you've learned, what you are looking here is already a differential equation. The idea in this equation is an equation. It's an equation, and it involves the derivative of your unknown function. Okay, it's an equation. What do we have here is an equation. It's relating. It points out a relationship, and what we have here is we have the derivative being involved in our equation, and that's why at the most basic understanding, a differential equation is an equation that involves a derivative. Okay, but so at the end of this problem right here, if we stop here, if we stop our understanding here, then nothing fascinating, because any of these, the point now is that when this equation is a little too simple. The point is the derivative is given explicitly. The derivative is given explicitly, and so with an equation being simply given like this, then we don't even need to learn. There's nobody going to need to learn nobody's going to have to take a class on differential equations to where we learn all of the different techniques. So what else is out there? What else is out there so that defines a whole class of the whole fascinating class of differential equations? So this one here is just one of the very small case which we need to go even a lot more beyond this. Okay, so I want to And that's what my point is. A differential equation has a lot more than just this. This is just the very basic that I just want to show anyone viewing the lesson here, learning from the lesson here, that you have seen the idea of a differential equation already. But now there's more than just being a differential equation. So allow me to bring in a different equation. Okay, and so having y being a sum function, tentatively unknown, but sometimes according to the deriving work, allow me to violate the order a little bit. Let's say from count 1. Let's say from count 1 right here, and I can call this a scenario number 2 right here. And I'm about to bring in some equation. But instead of just directly hand you the equation, I'm going to say, hey, back in count 1, a lot of times we know a function like this. Y equals some e to the x. Okay? And believe me, anyone reading this equation, anyone should be very familiar with this equation right here. It's a function. Y is a function e to the x. It's some function of x. Okay? Count 1, from count 1, and by the end of count 1, we learned that taking the derivative of that y, it gives me what? Or the dy dx, so now shortly y prime. It is simply the derivative on e to the x. But according to derivative rules that we've learned from count 1, the derivative of e to the x is e to the x. Okay? Or for short, you get putting this together, y prime equals e to the x. Really, y prime equals to the x. And so now if we look a little more closely, if we're looking at this final equation a little more closely, I also have my legal right to write this y prime equals e to the x as y prime equals y. Okay, y prime equals y. All right. And so now, of course, this one here is unfamiliar to anyone the finishing Calculus 1, because Calculus 1, your instructor didn't introduce it this way, but we added the problem here. And now I'm going to step forward. I was stepping forward and indicating, hey, we could have seen that, right? We could have seen that final result here as stating and making a statement that, hey, in the end, out of this result right here, y prime equals y. All right. And so now let me roll back to that time point right here. So with the equation just now you observed, y prime equals y, I gave a quick the development where it came from. But see, an equation like this, what I'm seeing now, y is, let's say, for anyone, all of a sudden you are being given an equation. Hey, here you go, there's an equation. In this equation, there's a y, and to that person who has this equation given right here, then this y right here is now seen as an unknown function. So we have an equation here that involves y, the function, being unknown for the person who has this equation given, and the derivative given. All right, so ladies and gentlemen, what we have here is another differential equation. What we have right here is another differential equation. It's an equation, and a derivative is being involved in that equation. But now, unlike the earlier demonstration I brought up in the first equation I brought up right here, then this equation also has y involved in the unknown function. And then ultimately, again, see, think for the person who has this equation, who was given this equation. Think about the person, or in the position of the person who was given this equation. That person is asked, find y. Because for that person who was given this equation, then the y is unknown for that person. Okay, because earlier I gave that quick little development, so I was in the position of the person who already knew and derived the equation. But think about, as a student, as someone who was given this equation, then for that person position, the equation, the function is unknown. This function is unknown. And so with the equation given, and just now I pointed out, this equation clearly is a differential equation. The goal again is, let's find out what function y that is. Let's find out what function y that is satisfying this equation where the derivative equals the function itself. Okay? And that's the whole reason why there's an entire course we learn different techniques of solving differential equations. Okay? So this is another instance where you're encountering a differential equation. But then let's not stop here at this quick little one. Okay? There's other, and you start recognizing, right, that the y variable as the unknown function itself may also be involved. Okay? All right, let me bring in another one. And so, again, y is a variable that represents some unknown function in terms of x. And now at this point I have to ultimately say anyone learning in this lesson should be fluent enough that the name of the inputs, the main input variable right here is not even important. Many textbooks in these days use a t as the main input variable. Right? This one right here could be t. Okay. The point is we have our flexibility in naming the input variable. Okay, some main input variable. But in the end, ultimately, y is a variable being some unknown function of whichever the input variable being indicated. Right? So let me bring in the next equation as another instance right here. Let's say y equals x times y. Y equals x times y. Okay? So what I'm seeing here, and of course out of this equation, you are asked to find y. Again, because for the person, and I'm now in that person's position as well. I have this equation given to me, handed to me by somebody else. Okay, and what I'm seeing, the way I'm seeing it right now, I have an equation. Okay, there's the main variable, the main input variable also somehow involved, and the unknown function being involved, and the derivative of the function is also involved. Okay, and I am asked to find the actual expression of the function as an expression completely in terms of x. Now, naively speaking, do not do this. And this is actually my own lesson that I've learned from first time being exposed to the world of differential equation. Naively, okay? I've done this. I'm dividing both sides by x, making it y prime equals x. So we found some expression for y, but this is not the solution to, this is not the answer to this. When you are asked to find y, it is intended that you gotta find the complete y in terms of explicitly in terms of x only. Okay? No more y prime involved. That's the point. So this was my mistake back then, and I'm calling that, it's, you know, naively, this is one way of doing it, but that's not really the welcomed solution. Okay? And so don't do that. Okay? And that's the whole reason why it promotes it comes up with the whole course in differential equations, that we can learn how to solve an equation like this. Okay? But in the end, the point is, once again, what I'm seeing here is an equation. It's an equation, it has the derivative of our function involved, and we need to find out what explicitly defined as a function that y represents. So we need to find y here explicitly. That's our unknown that we need to solve. And then in this equation, y is involved, similar to the earlier instance of that, and similar to the equation I brought up in the earlier instance. And then the derivative, a derivative, is also involved here. And there may be some main input variable, some other expression being involved, as the expression in terms of the main input variable is also involved. Okay? And that's another instance where you're looking at another differential equation. So this is a differential equation. All right. All right. And then as another instance, you are given an equation. What it reads here, y prime plus y equals 3x. And again, it's very similar goal, and it's the entire only goal for any differential equation, any work in solving a differential equation, which we will get to even more precise into that later. But what I'm looking here, we're given, or I was given an equation, okay? And in this equation, there's the function, the unknown function that we're looking for being involved here, okay? There's the main input variable being involved, and some derivative of, and I keep using that, you start noticing I use that term, some derivative of that function being involved. So throughout a few instances I've mentioned, then I've been using first derivative, okay? But some derivative of the unknown function. And then there may be some input variable involved here. So this one here is, again, it's a differential equation. A differential, and a lot of times for short, people call it a diff, for short for differential, diff EQ. Okay, diff EQ. Okay, a diff EQ. All right, so it's another differential equation. It's an equation at least one derivative is involved, and the unknown function may also be involved. In this case, it is. Okay, and then there may be some input variable involved out there as well in that equation. And our main goal, again, it's been 4 instances that I brought up. It's all about we want to find it. In our position, we want to find the y. For us, it's unknown. That's what it is. And we want to find the specifically explicit expression of the function y. Okay. All right, and here we are at another instance where you're having an equation like this. And again, you are asked to find the unknown function y. Okay, and so in an equation like this, we have the unknown function is involved. Okay, we got the derivative, the first derivative of our unknown function involved, and we also have some second derivative of the same function involved. So that, think about it in a more general case, in a more as a lot bigger generality out there, right? There may be up to like the nth derivative involved, and that's what I've been saying by a derivative involved here. So the earlier instances where I brought up the earlier equations, those are just first order the derivative involved. But here it starts opening up in our understanding. The derivative can be even higher order, like second order or third order, or nth derivative and all that. So what I'm having here is, again, a differential equation. It's a diffq. Okay, and the way how I'm seeing it, the functions, the unknown function that we're looking for is involved. In this case right here, the x, the input variable, the main input variable was not involved in this. That's okay. It may or it may not. Okay, and then there is a derivative, at least one of the derivatives involved. And here we got 2. We got both. We got the y prime and the y prime prime. Okay, so what I have here is clearly a diffq. And again, the ultimate goal, we want to find out which function is that, is to satisfy this. Okay, and so at this point, after seeing 5 instances, and these are not the only 5 differential equations, please do not get me wrong with that. Okay, these are not the only 5 differential equations. I just brought up a few scenarios, a few instances where for you to realize it, and so that we can come up with a generalization of what a differential equation is, what a diffq is. And so now let's go ahead and look at the formal definition of what it means by being a differential equation on the computer screen. All right, so we are now at the definition of what a differential equation is. So a differential equation is an equation involving an unknown function, y equals f of x, and one or more of its derivatives. And so just like the demonstration I've done on the board earlier, y is some unknown function, and one or more of its derivatives. And so we've been looking at a mix between y prime or y double prime, or even higher order. All right, and so now that you have seen the definition on the computer screen about what it means by being a differential, a differential equation. And so I gotta emphasize a couple things right here. So now you will hear people, and including me, your instructors, and other professors, and maybe saying things like this. So from now on, you hear people asking you to do solving, right? So when you're asked to solve, right? Okay. Anytime you're asked to solve a given diffq right here, a given differential equation, or in short, solving the process in solving a differential equation means the same. So allow me to illegally use equal sign. It just means a means, right? It means the same as finding the solving any given diffq or solving any given differential equation means the same as finding the unknown function y equals f of x. And that's one way. So you will start hearing me saying this a lot of times, and including many other professors out there. Hey, here you go. Here's your equation. Solve this equation for y. Solve that other equation for y. Okay, but it means we want to find out what expression, what function explicitly define the y here. Okay, and so that's one highlight right there. Okay, and now another highlight right here. See, and think about once you have solved your equation, once you have solved your differential equation, starting out with a given equation, and you found it. The found, whatever your found answer right here, your found the function f of x to be equal to y that satisfy your equation. That's why I'm using that term right here, the found y equals f of x. Right? Okay. So the answer there that you found from the equation, right, the function that we found right here, is now called the solution to the equation. See, the process here is solving the differential equation, and once you have found what that unknown function is, right, that final unknown function now that is found is called the solution to the equation, to the given diffq right here. Okay, and that's the idea. All right. All right, so now allow me to bring up one example, okay, for you to get comfortable with operating with a differential equation right here. And this example is not to solve an equation yet. We haven't learned any technique, any solid technique yet. Okay. All right, so here we are, this example. Let's read the instruction of the example. We are asked to verify that. So now I'm seeing this given y equals e to the 3x here as a given function. But now think about it in our position, and we have a differential equation right here. So the instruction of the example is asking us to verify that this is a solution. But so a solution, or wait a minute, that could be maybe other solution. That's not important. But being a solution means this known equation, this known function, this function now known because it's given to us, this known function better satisfies this differential equation. Okay, so for us, in order for us here to verify that this is a solution to the given differential equation, all we do is substitute it into our equation here. The concept is very similar to the very early days when we first learned about solving any equation. Okay, like long ago when we start learning how to solve an equation, like even the most basic equation, and we learn about, hey, here you go. If somebody claimed that this is a solution, what do? Most naturally, we substitute that found or known solution into the given equation. Okay, and if it satisfies and maintain equality with the known solution, with the known function given right here, then that means yes, now the solution is verified. Okay, so now in that goal right here, this is what I'm doing. Now y is known, is given to be equal to 3x. In the equation right here, the left-hand side is indicating y prime. So y prime on the left-hand side immediately, according to the function given right here. If that truly is, or if that truly was the solution, then the y prime should come out equals, well, we take the derivative of e to the 3x. That's the start. And then taking the derivative of e to the 3x right here from calc 1, that gives me 3 times e to the 3x, according to the rule for taking derivative of an exponential function, and with some little chain rule applied here. Okay, and so now in the way how I'm seeing it, putting this long lengthy line together, I can lead down to making a final conclusion. So y prime must equal to 3 times e to the 3x. So that's easy to follow for anyone. Okay, but so now e to the 3x itself is equal to y. So that means I can further conclude that y prime is 3 times, but the e to the 3x component that I underlined with the brackets right here, that's y. Okay? And so now we sit back and look at this a little more closely, and we've like, wait a minute. So that is the equation. So that is the equation here. And that means what? We have just now verified that with this known function y equals e to the 3x, substituting that into the equation, we have this equality satisfied or maintained. So that means what? It's now verified. It's now verified that y equals 3 to the 3x. Y equals e to the 3x right here is a solution. Okay? And so now I have to emphasize what it means by being a solution. Because we are only given one equation, and at this point in our learning, in our lesson, we haven't learned all of any solid technique to find out all solutions or a general representation of all solutions out there yet. That means there may be other functions out there, other known functions out there, other functions out there we haven't found that also satisfy the same equation here. That's why this solution being given to us right here is only a solution. Okay? And so in this kind of example right here, my intention is that a lot of times you're simply given your differential equation, and then some known function is given to you. It's simply some known function given to you, and you are asked to verify that that this is this given function, this known given function, because it's given, right? We're asked that this known given function will be is a solution, qualifies to be the solution of this given equation. That's what we do. We substitute that into the equation and make sure at the ultimate ending right here, it's after substituting that known function into the equation, we maintain equality of our equation. All right. And so that's the whole goal of this example, and also gets you comfortable with using the term the solution or a solution of a differential equation. Okay. All right, and so now allow me to bring back those equations I brought up earlier in the different instances where I pointed out there are always differential equations existing. So, including the very basic one that for the more advanced course and for any more formal class in differential equation, people almost never have to concern about these, including that basic one like y prime equals 2x. That was a differential equation. Then we had y prime equals xy, and then we had y prime equals y. I may be a little bit out of order compared to the order of how I wrote down these equations earlier. And then we may have y prime, okay, plus y equals 3x. And then there were y prime prime, right, minus y prime equals y. Right? So these were the differential equation I brought up earlier to demonstrate, to point it out as example that there are differential equations existing out there. And so now let's look even a little more closely. Now these equations that I'm now pointing at, the first four on my list right here, they only involve the highest derivative involved here ever. It's the first derivative. All right, and so now that any of these guys that my red arrow points to, we refer to them as a first order differential equation. Okay, so first order simply means only the first derivative involved. And that's the highest order of the derivative involved in your equation. That's called first order differential equation. And so if that's the first, if these are the first order differential equation, then we won't cover that in our lesson here. But I'm assuming anyone viewing the lesson here will eventually advance to a formal course in differential equations. So what do we call something like this? Now it has first order derivative, but it also has the second order derivative involved here, the second derivative involved here, or the highest derivative order that involved here is the second order. And so something like this, yes, when you enroll into in a future differential equation or in a formal differential equations course here, this one here is regarded as a second order. That is a second order DFQ, okay, or second order differential equation. Okay, all right, and so now I'm going to summarize all of this into a somehow a formal worded definition on the computer screen about what it means by being a first order differential equation. Okay. All right, and so in that way, a differential equation is of first order, and generally we call that it's a first order differential equation, or even in short, first order DFQ. It's a first order if the derivative involved is the first derivative. All right, in this example, the instruction of the example is asking us to determine which one in the given list of differential equations below is classified as a first order differential equation. And there could be more than one. And so we're going to check all that applies. And so what we're looking here is to find out which one among the lists given below here is being a first order differential equation. All right. And so in the example right here, the first equation that was listed, y prime prime minus y equals y prime. That first equation on our list, it is clearly a differential equation. But now from what I have now recognized right in front of me and right in front of anyone learning from the lesson right here, then the highest derivative is up to the second order. The highest derivative order is a second derivative. Okay, so in this way right here, this one here, second order. Okay. But so the question wants us to determine which one among the given equations being a first order, then this one here being a second order, it fails being a first order. So this one here is not a first order differential equation. Okay. That next one on the list. All right. So this one on the list right here. It is a differential equation at this point in our understanding. The highest derivative order is the first order, or now we can see that the only derivative involved here is the first derivative. And so now, yes, this one here, according to the definition, is the first order derivative. And so the instruction of the example says, let's determine, right, which one among the given equations being classified or being considered, right, as the first order. This one here qualifies. Okay, we put a check here. So that means this one now is a first order differential equation. Okay, so for this equation, once again, another one on our list there. Let's find out if it's a first order or something else. Okay. I've got y squared, I've got 1, but this is just the function y being involved with a power right here, and there's 1/2, all the fancy thing, but once again, the highest derivative order recognized here is just the first order, or in other words, another way of saying, I have only spotted the first derivative being the highest derivative, okay, the highest order derivative. And so in that way right here, yes, the equation here as a differential equation now is classified, right, or is determined as a first order differential equation. And so this one here is another equation that qualifies being a first order differential equation. We put a check on that. Okay. And so this one here in our list is also another differential equation.